Welcome to Ask and Learn.
We want to show that the curve y is equal to x minus tangent inverse of x has two slant asymptotes, being at y is equal to x plus or minus pi half. And then we want to use these slant asymptotes to help us sketch the curve. Now remember, to show something has a slant asymptote, what we're going to want to show is that the limit as x approaches plus or minus infinity of f of x minus g of x is equal to 0, where this function g of x would end up being our slant. All right, so let's go ahead and first get some inspiration as to which of these we should use for plus and minus infinity. So we know the limit as x approaches infinity of x, so the limit as x approaches infinity of x, well, this goes to infinity, and likewise for negative, this goes to negative infinity, so that doesn't really give us anything. But tangent inverse, so the limit as x approaches tangent inverse of x, well, we know that this here approaches pi half, and we know the limit as x approaches negative, so negative infinity of inverse tangent would be negative pi half. So given this information, we might suspect that as y tends towards infinity, so our original function here, it would go to x minus pi half, and then as it tends to negative infinity, it would go to x minus negative pi half, or x plus pi half. So let's go ahead and show that those two slant asymptotes are actually the case. All right, so we want to show first the limit as x approaches infinity of, so x minus tangent inverse x, and then we're going to do minus x minus pi half. So here the x's will cancel out, and we'll be left with the limit as x approaches infinity of negative tangent inverse x plus pi half, because this negative here gets distributed to that. And then we already said that the limit as x approaches infinity of tangent inverse should be pi half. So we'd get negative pi half plus pi half, which is 0. So that one checks out for being our slant asymptote as this goes towards infinity. Now, to show the other one works, so maybe I'll write this over here. So x minus tangent inverse of x, well, that tends towards x minus pi half. And now we can do the same thing for the other one. So the limit as x approaches negative infinity of x minus tangent inverse x minus x plus pi half. Well, again, the x's here will cancel out. And then we can go ahead and let's just apply the limit right away. So the only x that we have left is right here. So that would become negative pi half. So we have negative pi half. And then distributing this negative to that would give us minus pi half. So these two negatives cancel out, and then we have pi half minus pi half, which gives us 0. So that is also a slant asymptote. Oh, so actually I should put this is for infinity right there, and then our other one, so x minus tangent inverse of x, this here will tend towards x plus pi half when x is going to negative infinity. All right, now let's go ahead, and one other thing we might want to do if we're going to graph this is plot our intercept. So let's do that over here in this bottom left corner. So we want to let x equal to 0. So we're going to have y is equal to 0 minus tangent inverse of 0. Well, tangent inverse of 0 is going to be 0, so we get 0 minus 0, or just 0. So we know that the origin will be one of our points on our graph. Now, I went ahead and plotted the two slant asymptotes here. And so we know that 0, 0 is a point. So let's go ahead and graph that really quickly. So that's going to be right here. And now we know as x tends towards infinity, we should tend towards x minus pi half. So the graph should look something kind of like this, getting really close to the red line. And then we also know that as x tends towards negative infinity, this function should get really close to x plus pi half, or this blue line. So this is how we could go ahead and just get a sketch of this graph without doing too much work using our two slant asymptotes.